Hello and welcome to today's lecture on field effect transistor. So today we are going to discuss on the second module, that is the field effect transistor. So before going into the field effect transistor, let me show you something else. Um, we all have studied about the diodes. So diode is nothing but a two-layer, two-terminal device where you connect the potential, the external potential, either it is the positive potential, so that will make it the forward biased. And then what will happen when you connect this a positive battery to a anode and a negative terminal of the battery to a cathode, so this will make the diode in a forward bias condition. When you make the diode in a forward bias condition, so what will happen, the holes from P will jump into the N region, and likewise the electrons from the N region will cross the junction and goes to the P region, and it will start recombine. So here the holes are nothing but the represented as plus, and here the electrons which are nothing but represented by minus, so both will contribute. So it means, so in the flow of current in the diode, so here both electrons and holes are moving across the junction in contributing in the flow of current. Now the same concept is also applicable for the transistor, because before we discuss on the Jfe T, we should understand the concept of transistor. So this transistor, we call it as a bipolar junction transistor. We call it as BJT. So BJT stands for bipolar junction transistor. It means both the polarities, the positive and the negative charges, will contribute in the flow of current. Now, as you know, the transistor is nothing but it consists of three layers and three terminals. So which are the three terminals? So the three terminals are nothing but the emitter, base and collector, and the three layers are, it can be PNP or it can be NPN. So now when you make emitter base junction forward biased and collector base junction reverse biased, then what will happen, the holes from P will cross here and electrons from N will go to the emitter region and it will start recombine, and again due to reverse bias condition the minority charge carriers will flow like this, so thereby there is a flow of current. So in both cases there are both the charge carriers, that is holes and electrons, are contributing in the flow of current, and ultimately there is a flow of current from emitter to collector. And the responsibility or the role of this base is to control this flow of current from emitter to collector. So to control this flow of current, basically this is controlled by IB. So IB is nothing but the base current. It means the BJT is a current controlled device. What is BJT? So BJT is a current controlled device. So if I write here, so it's a current controlled device. I'll just write it as DEV to understand for device. So BJT is a current controlled device. So this is about basic BJT. Now if we look at the let me save this for a moment. I'll save this in the downloads as my page 1, or let me save this in my folder. Sorry for this, there is no pause in between. I'll save this as page 1. Why? Because I have to clear this. Now we are talking about the Jfe T. So Jfe T stands for junction field effect transistors. So Jfe T stands for junction field effect transistors. So basically there are broadly two categories of junction field effect transistors. So the two categories nothing but basically it is field effect transistor, FET. FET means field effect transistor, and there are two categories of field effect transistor, that is junction field effect transistor and metal oxide semiconductor field effect transistors, or in short it is called as MOSFETs. This is FET, field effect transistors. And junction field effect transistor, in turn, it has two types, that is N channel and P channel JFET. And MOSFET, again, it has two types, that is depletion type MOSFET and enhancement type MOSFET. So these we will see later. And again, in both of these, again there is a N channel depletion type MOSFET, and in enhancement type also we have two types, that is N channel enhancement type MOSFET and P channel enhancement type MOSFET. Okay, so this is about the introduction of JFET. So let us revise again. So field effect transistor has broadly two categories, that is junction field effect transistor and metal oxide field effect transistor. And junction field effect transistor has again the two subcategories which comes under this. This is nothing but JFET we call. In that N channel JFET we call this as JFET, N channel JFET, and P channel JFET. And in the MOSFET, again we have two subcategories, that is depletion type MOSFET and enhancement type MOSFET. And again, depletion type and enhancement type both are of N type as well as P type. So this we will see later. So now let us jump into junction field effect transistor. So now let us look into the okay. So I explained you about BJT. Now let us compare this BJT with JFET. Let us compare these two. What is the difference between these two? Now JFET is a voltage controlled device, whereas this is, I'll write I to represent the current. So BJT is a current controlled device. So this is one of the difference. And BJT has high input impedance. I'll write IM to represent impedance. And whereas this BJT has low input impedance, sorry, I'll write it as IM. And the JFET has low output impedance, that is, I'll write it as O0, and BJT has high input impedance, that is nothing but, I'll write this as I0. So these are the basic differences between the JFET and BJT. So BJT is mainly used for amplification process, as JFET is mostly used for switching operations, because its performance is very good in terms of fast switching, because its switching between on and off state is very high when compared to BJT. So there is a special kind of JFET that is available, that we call it as IGBT. It's a special kind of JFET, IGBT, so which is used for high speed switching applications. Okay, so now let us revise the main difference between the JFET and BJT. So BJT is a current control device, JFET is a voltage control device. It means here the gate terminal use the current to control the BJT, whereas here the gate terminal use the voltage to control the JFET. And the JFET has high input impedance and BJT has low input impedance, whereas the JFET has low output impedance and BJT has high output impedance. So these are the basic differences. So let me clear this. I'll clear this. So now we will look into the basic constructional diagram of N channel JFET. So we will discuss on N channel JFET. Sorry for this writing, because I have to write from mouse. Sorry. Let me erase this. Jfe T. Okay. So now to construct JFET, we will take a substrate or a material, whether it might be a P-type or N-type material. So assume we have taken a N-type material here. On n-type material, we will diffuse two p-type channels. So this is p-type, this is p-type. So this entire region, the base, is nothing but it is of p-type material, and on top of it we have diffused two this entire base region is n-type, and on top of it we have diffused two p-type materials. You can think of it as a pizza where base is nothing but the bread, and on top of it you put some stuff on it, so that is your p-type. So now it has, like BJT, this also has the three terminals. In fact it is four terminal, but these two terminals are shorted together and it is called as gate, and whereas this we call it as drain. D stands for drain, and this is source. So JFET basic constructional diagram looks like this. So we have taken a N channel, or we have taken as a N substrate. On N substrate we have diffused two p-type materials on the either side, and this there is a metallic contact to this p region on both sides, and both are shorted together, and we call it as a gate terminal. And on both sides of this N substrate or N material there are two metallic leads which are connected, so that we one end we call it as source and the other end we call it as drain. So this is the basic construction. So if I want to write, so this is called as N channel JFET. So if I want to construct a p channel JFET, then I have to take a p substrate as the base. So now the base is of p type, and on p type I have to diffuse two n channel two n type materials. So now this is your n on both sides, which is diffused on the p substrate or p material, and these two leads are shorted together, and we call this as gate, and this is drain, and this is source. Okay, hope you all have understood this, the basic constructional diagram. So S stands for source, D stands for drain, D-R-A-I-N, drain, and G stands for gate, and S stands for source, S-O-U-R-S-E-C, source. Okay, so it stands for source. So this is the basic constructional diagram of N channel JFET and P channel JFET. Why we call this as channel? Because the same material. So one more difference I forgot to tell you when we are comparing about the BJT and JFET. So one of the major difference between FET and BJT is BJT we call it as a bipolar junction transistor, and FET we call it as unipolar junction transistor, because here only one type of charge carrier will contribute in the flow of current, whereas in BJT both electrons and holes are contributing in the flow of current. If I open this diagram, let me open that, so that where did we saved it? Okay, it has come to the wrong page. So if you see in this diagram, so whenever it is emitter base junction is forward bias, both holes are moving from P to N, whereas the electrons are moving from N to P. So it means both electrons and holes are contributing. So that is why it is called as bipolar junction transistor. But whereas in JFET, we will see the working of JFET. So in JFET, either only N electrons or only holes will be contributing. Now for example, in N channel JFET, only electrons will be contributing in the flow of current from source to drain, whereas in P channel only holes are contributing in the flow of current from source to drain. That is why it is called as unipolar. It is called as unipolar junction transistor. Uni means one, bi means two. That is why transistor is called as BJT transistor is called as bipolar junction transistor, and JFET is called as unipolar junction transistor. So now next we will look at the working of the JFET channel. I will see these in the next tutorial. So till then, goodbye, take care.